Alright guys, back at lesson 3.2 here, volume, cubes, and cube roots. So in the last section we got into area, right? And again, the difference between, just like a regular length, okay, which is considered one-dimensional, that might be like 1 centimeter. Then when you get a width or a height, you're able to get an area, okay, with a length and a width, which is now in square units. Okay, it's how many squares would fit. Now, if we extend to 3 dimensions, if we include height as well, and you want to ask how much material would fit inside the box or inside the cube, we are now talking about volume. Okay, so that's going to be a cubed unit instead of squared. To cube something is like to the 3rd power. So think of like a room, a classroom, the area of the floor may be a rectangle or a square, right? Length times width. When you multiply that by the height of the walls, okay, then that's going to tell you the volume, or in other words, how much could you fit in there? How many cubes could fit in there? Okay, or like how much water could fit in there or something. It depends on height as well. Okay, so let's jump into that a little bit. If we see the diagram in the middle of the page here, that's a cube, and let's say the dimensions are 1 foot by 1 foot by 1 foot. So the volume, there's a formula for volume that we will see in just a minute for a cube like this. Again, it's just the length times width, which is the area, and then multiply that by the height. Okay, so let's dig into it and let's see what's going on with example A. Okay, so let's find the volume of a cube we built with edge lengths of 2 units each. Okay, and we'll find the volume in exponential form and in cubic units. All right, so they had asked us to, right above there, let's build a solid cube with dimensions 2 units by 2 units by 2 units. Okay, so if you imagine if we had a cube here, and let's say again it was, let's try and draw something here. Let's see. Do this. You guys know how to draw a 3D cube. You draw the 2 squares like that, and then kind of connect the 4 corners. For a real good artist, you might use like dotted lines for the back edges that you don't see or whatever. But let's just say again, let's say it's 2 units tall, 2 units wide, and a length of 2 units. Okay, so to find the volume down at step 2, we're going to write the volume with a base number and an exponent. So since volume is length times width times height, it is 2 times 2 times 2. And we saw a little bit in the previous section about bases and exponents, that this is really just 2 being multiplied by itself a total of 3 times. So a way to write that as an exponent form is 2 to the 3rd power, okay, like this. Notice the 3 is raised, okay, it's called a subscript. I'm sorry, a superscript. Subscript would be lower. But anyway, so the volume is, as an exponent, 2 to the 3rd power. And if we multiply that out, of course, 2 times 2 times 2, right, is 2 times 2 is 4, times another 2. The actual volume of this would be 8 cubic units. All right, so let's dig in a little bit here. Let's try these. Can we complete this table here to show the volume of each cube in exponential form and also in cubic feet? So they did the first row for us. If that was the one we just did, actually. If the length was 2, since it's a cube, the length, width, and height are all equal to each other. So the calculation for finding volume, length times width times height, is 2 times 2 times 2. We can write that in exponential form as 2 to the 3rd power, which equals 8. Okay, if it was 4, we would be doing 4 times 4 times 4. Okay, and to write that as an exponent, the base is 4, because that's the number we're multiplying. And there are 3 factors, or what they're called, of 4. And 4 times 4 times 4 is 64 cubic feet. Okay, what if the length of the edge was 5? Right, again, length, width, and height would all be 5. Okay, 5 to the 3rd power. 5 times 5 is 25, times another 5 is 125. Okay, and again, cubic feet is the way to go here. Let's just jump down to 9 so we can see how quickly these numbers grow. 9 times 9 times 9, right? 9 to the third power is 729 cubic feet. So these things grow pretty quickly, right? We're already up to 729 cubic feet. Right? So the exponent used in each exponential expression of volume is the same, right? This exponent can be used for the volume of a cube. Using this exponent is known as cubing a number. So when you take something to the third power, that's called cubing. Okay, just like in the previous lesson, we took things to the second power, right? To find area, it was like length times width, and that's called squaring a number. Okay, so let's find example B. Find the cube of 10. Okay, which is saying 10 to the third power. So 10 to the third power again just means 10 times 10 times 10, right? The exponent tells you how many times you're going to multiply the number, and that is 1,000. Okay, there's a few examples there. We actually did 3 to the third in the table above, didn't we? Well, that one equaled 27. Okay, and these are probably just calculator problems. You might know some of them in your head, but 7 times 7 times 7 is 343. Okay, 11 to the third power, right, is 11 times 11 times 11, 1,331. Okay, and then 1.5, again, I'm just using the calculator, times itself 3 times got me 3.375. All right, so let's work backwards a little bit now. Let's say, what if you know the volume, okay? So you know the volume of a cube. You can determine the length of the edge. So the operation you use to find the edge when you know the volume is called finding the cube root, okay? If you remember last section, we found square roots. So cube roots are similar, okay? But we're finding what number could be multiplied by itself 3 times to equal the volume. Okay, so first off, let's just get some answers down, and we'll talk about maybe how to do these and some calculator tips. But if the volume is 1, right, what must be the length of the edge? Okay, so basically something times itself needs to equal 1, where all of these numbers need to be the same. Okay, can you think of a number times itself equals 1? Yeah, the answer is 1. Okay, because 1 times 1 times 1 equals 1. What about if the answer were 8? What times what times what equals 8? And again, each thing we're multiplying needs to be the same. Okay, in this case, 2 times 2 times 2 equals 8. Okay, so if the volume is 8, that means that the length of the edge must be 2. Okay, what about 27? Well, let's just see. Let's just check. What is 3 times 3 times 3? Right, well, 3 times 3 is 9, times another 3 does equal 27. Okay, so if the volume is 27, the length of the edge must be 3. And similarly, if we checked 4 times 4 times 4, that would equal 64. So 4 would be the length if the volume is 64. Okay, so there's a couple ways to do these. The first few, like these ones in this table, after you do these a couple times, you'll kind of recognize that they show up, and these are called perfect cubes. But like bigger numbers, like you might not know, for example, that 343 is a perfect cube. Okay, so let's just say, what if this table continued, right? What if 343 was on there? If the volume was 343, what would the edge be? Okay, and you don't want to just like guess and check a whole bunch of numbers. So what you can do, there's a button on your calculator, actually the symbol right over here for cube root. So we would be looking for the cube root of 343. Okay, on the graphing calculators, you need to push the math button, which is it's in the far left column, about third or fourth button down. Press that math button, and then when you scroll down, you will see that symbol, and then you can type in 343. Okay, or it may be somewhere else, and you'll get the answer is 7. It may be somewhere else on your calculator. You can always just just search online your calculator model and then type in cube root, and it hopefully will tell you how to do it. One other option I want to show you guys how to do, if you need to find the cube root of something, and let's say your calculator doesn't have that button or you can't find it, the other option is, instead of doing a cube root, you can use an exponent. Okay, and some calculators have a button like it looks like a little up arrow. We actually call it a caret key. That's where you can put an exponent in, and the trick is, and I don't want to get too far into depth with this stuff because it'll probably come up later, but if you want to find the cube root, that is the same as raising something to a fractional power, to the 1/3 power. So 343 to the 1/3 power will get you that same answer. So that's just an option if you don't find the cube root button. But again, it might be complicating it more than it needs to be at this point. Okay. All right, and they actually walk through on the next page of the example we just did, finding those cube roots and finding the answers that we got. Okay, so in this section, it's really just going to kind of be some calculator work. Okay, you know, the check your understanding, you'll see these are just calculator problems, very similar to what we just did. The one connection, if we want to look like at number 5 again, just remember if they give you the volume, okay, like in the table in number 5, and they want you to find the edge, they're giving you the cubed value. So to find the length of the edge, that's when you would need to take the cube root of the volume and actually get a value. So for example, that first one, the 216, if I'm throwing that in a calculator, the cube root of that is 6. Okay, and sometimes you can just try things. You could try like 6 times 6 times 6 and see if that works, or if it was too small, you know, try 7 times 7 times 7 or whatnot. Just a little guess and check. But the cube root button is a way to kind of get the answer for sure. Okay. All right. So you guys' assignment will be on page 40 here. We're going to do numbers 6 through 11. Let's see. It should be similar to what we did in the notes. Just take a look. Number 11 there, when they're having you solve an equation, is basically what we just did. If something cubed equals 64, let's do part A together. If x cubed equals 64, okay, just like in the section from the other day, we had x squared equals something, right? We would take the square root. So here we are going to take the cube root, and then you can throw that in your calculator and you will find that the answer is 4. So you're basically finding the side length when they give you the volume.